Right, we're back at Gluware Intent 19, and we're going to continue with some demos from Merck showing off what they are doing with Gluware, and I'm going to hand it off to Mike and Sal again.
Great, thanks. All right, now the fun part, right? Seeing some real work get done. Well, not really, it's a demo lab, but we'll still have some fun with it anyway. We can break it, it's fine. We've invited Alex, one of our system engineers, up to run the hands-on, because I cannot type and talk at the same time. So with that, we're going to do 3 examples based on Merck, and then a few of the other things you heard about, audit and upgrade, we're going to actually do in a little further segment with another customer. So very first here, we want to jump into a use case that is really kind of what I consider the starting point with Gluware, which is using the device manager, which is a built-in component of Gluware Control. And this is about getting your hardware and software inventory. So the Gluware Control engine, all we need are IP addresses and credentials. Our engine runs either on-prem, you can install it as a virtual machine, one or more virtual machines in your infrastructure, or we can run from the cloud. When we run from the cloud, we need to hop through a proxy so we can hit your network devices. But essentially what we've built into the product is the ability to take a real inventory, real-time inventory. So we go out and connect to all the devices, and we have a piece of software called the Device Detect Engine that runs a series of commands to determine what vendor it's talking to, what operating system. Once it knows those pieces, like on a Cisco, it's pulling a show run, show hard, show ver, show, a bunch of show commands, and then pulling those into a data model. And so it gives you a real-time inventory of what's on the network, and it's extensible, meaning if there's something else you want to capture, it can be added to it. So with that introduction, one new piece to mention was with our 3.5 release we announced last week. It's been in production at several customers for the last several weeks. We've taken what we've talked about with the Cisco APIs, Cisco support APIs, which do need your credentials. We don't provide your own Cisco support credentials. You hook those into the product, and then we can go and pull SmartNet, end of life into sale, and the security advisories on that hardware based on the inventory. So those are some of the pieces we're going to show you here. All right, so Alex is logged into Gluware Control here. It is multi-user and multi-tenant. With a tenant, we call it an organization. That just means that, let's say your data center nodes are separately administered than your WAN nodes, or maybe there's a team of people who do your firewalls or load balancers. You can set those up as separate organizations. Multi-user with multiple forms of authentication into the platform, supporting LDAP, Radius, using your own Radius to authenticate into the platform. So once you're signed in, if you want to jump back to the home page there, you kind of select your app, and in this case, Device Manager, you navigate into, and what Alex is showing here is you haven't, okay, so it's a clean slate. So Alex, maybe you want to talk to what you're showing.
So basically what we've done here, right, this is a clean import of devices, and I have not done any discovery. You can do an import through a CSV, or you can do an import from your model editor, or just simply add device one by one. So once you have your inventory, it's basically a matter of, you can do the discovery on one, or you can select all, and I will do a live discovery that kicks off, and you have the discovery status. That is, the engine is logging into each device and running the set of commands into each of those devices and gathering information about it. In this case, one of them has already returned.
So what you're seeing is there's some delays in terms of running all the commands that need to complete and then pulling that data in. The engine is actually very highly scalable. The piece that actually goes and talks to the nodes is called provisioning engines, and we can spin up multiple, and we can even place them geographically where it makes sense. And so that was actually an enhancement that came out 3.1 or 3.2, I can't remember the release now, but essentially we decoupled the provisioning engine from our primary orchestration engine, giving us massive scalability. In fact, we've done changes to 14,000 nodes in under an hour, to give you a sense of scale.
Right. So what we've done here is we discover the inventory and information about the devices. What we haven't done yet is once you do provide your access to the Cisco API, your credentials, you have access to be able to discover information about the hardware and the vulnerabilities and the life or any other information about it. So that's what I'm about to execute here right now. So this goes out to the Cisco API, does a call, and does a call on the SKU numbers of the platforms and on the software running on those devices as well. So that should just take a second here.
So again, Alex is demonstrating something we're going to go into depth a little bit further into how Gluware can interact with third-party APIs. We're actually consuming Cisco APIs. This has been productized, right, into Gluware, where it's something you don't have to build or do anything, it just is working. There's other examples that we'll talk to again in more depth later, where we can interact with other APIs like ServiceNow or Jira or an IPAM for address management. So Gluware certainly has the ability to kind of talk API, in this case, not necessarily down to network nodes, but in this case kind of east-west to other aspects of the management plane, in this case a vendor API that is slow to come back. But that's why I'm tap dancing.
So the return information, right, on these devices that I have in the lab, I don't have any support contract. There is no end of life available to them. I do see some high advisories on vulnerability information, right? So, and I can click into the details of what that information is, right? Based on the iOS that I have running on that device, there's multiple vulnerabilities detected. You can go into a more in-depth view of what those vulnerabilities are, and you can also go read that information on the Cisco site, right? It goes directly into there. You also have the capability of saying, what are the versions that are affected, and you have quite the large list of iOS versions that are running with that vulnerability.
So a couple comments on this is that this is a new integration, and we're getting some great feedback from customers. One is I've done the assessment, and let's say you still have to do a determination of what is my risk to this advisory. And so one feature request that came is the ability to just say, okay, I've assessed this one, let's suppress this because it doesn't affect this. So something we're definitely looking at. Another piece is when you read these descriptions, some of them describe if you're using certain configuration statements. So it's not just the operating system level, but it actually dives into the config statements being used that expose. At our current state or assessment, unfortunately, we can't just translate a vulnerability into an audit policy, but we do pretty easily give you the ability to just take config statements, put them right in the audit engine, and then go assess the network to see if you are exposed. And so right now, it's a little manual translation from the advisory into the audit engine. But once you have it, it's a one-click to determine, do I have any violators? And you're going to see that in an upcoming demo. So that, from an inventory and the pcert component, this is pretty much, just wanted to show you that it's real. It pulls all this stuff in real time. Alex, if you can scroll to the left on the lower grid, we were at a customer who was using a vendor product. Won't name vendors in the actual product, but they said we had feature requests in forever to extend the commands and pull in a certain stat. They wanted the uptime stat in the grid. And so, we went on a little break, and one of our engineers in the room extended our capability in a matter of minutes, and it kind of came back from a short break, and he said, oh, that feature you wanted? Oh, it's in the product now. And obviously, we hadn't pushed it to production, but in that instance, we reran inventory, and it was pulling in the uptime stat. So just an example of that, the Gluware team is responsive, and our ability to extend what we're pulling from the network is certainly extensible to your requirements. So with that, we're going to, let me jump here to set up demo number 2, which is based on config modeling. Again, we described config modeling in the first part, but let's say the summary level view of config modeling, again, it's an approach where it takes older concepts that people have been using of, taking existing CLI with the 20-year-old load and pray technologies, just take CLI and push it. It takes templating and it modernizes all those concepts. So what we do is essentially break down monolithic CLI configuration into feature components that, again, behind the scenes are data modeled. We happen to wrap it in JSON-based coding. To the end user or CLI user, you don't really have to care about it. but just to know that there's underlying technology that is data modeling this and making it automatable and reusable. And the fact that we pull from your existing device or example configurations to create these models, and these become the desired state, the intended policy that the declarative engine will go and compare and read, compare, verify, and then make the required changes to make that desired state the end state. So again, we'll go back to Merck's use case of deploying QoS. And again, with QoS, it took updating SNMP for monitoring and NetFlow for monitoring, and then other components of automation. So with that, we'll jump back to the live demo setup. So Alex, maybe best if you drive and talk, unless you.
So with the use case with Merck, right, they had their quals policy set up, and it was just a matter of trying to build those models inside Gluware. So as we explained earlier, right, we created the different blocks of, that represents your CLI. So I have my access list, right, and of course we sanitize this. It's not exactly Merck's information here. But yeah, you build your access list.
I'm only kidding.
Yeah, we build your access list, right? Then you got your class maps. And with the class maps, right, even though we can create multiple models or multiple sets of class maps within here, we don't have to use the intended what's in here, right? So what I mean by that is I could have multiple sets of class maps in here, and I could use a filtering that's only going to call a section of them, right? So you can use a further filtering to create more of a focus point on what you're trying to configure, right? And on top of that, right, there are certain types of CLIs that are supported in one devices but not supported in other type of devices. So in your CLI model, you have the option to create, this is compatible by OS version or by SKU version, by SKU number. So at the time that the engine is doing the provisioning and is logged into that device, he understands the SKU number of that device, and he says, hey, I matched that regular expression. This CLI is supported on this device or not, right? And the same thing with the OS version as well. Yeah, so we have access lists, we have the class maps, then we have policy maps. Again, with the policy maps, I can have, two separate set of policy maps, but I don't have to call out these full policies, as I can go to the filters and say I only want to do the tagging of the packets. And for another one, I want to do the queuing of the packets, right? And the other condition as well was on which interfaces to configure the correct access, to the correct policies, right? What interfaces do I want to push that to? And with the conditional, advanced rendering conditions, you have the capability of, say, if an interface has matching a regular expression, which can be defined by the user, anything that exists on that interface, in this case was simple switch port access mode, you choose one type of policy. And a different case would be if you had switch port mode trunk, right? Then you select a different service policy. So with the model built up, right, I have everything attached to the assembly, and right now we're going to run a preview to make sure that this is what you intended to push. When it comes to preview, when it comes to actions, you can schedule that action and to be performed at a later date, or you can just do it manually, right, which is what I want to do right now. But with the preview, you have three types of preview. You can do a model validation to make sure that your models are all built and connected and you don't have anything missing. You can do initial preview, which is going to give you a printout based on the models alone without comparing what's running on the device. And then the connected preview, which is the top level, that's going to give you a comparison or a preview of what the engine is about to do, considering what's on your running configuration. So that's what we're going to do right here. It's going to connect to a live switch. And in the log view, you have the capability of select which log levels you want to see. I'm going to remove debugging. I don't want to see the CLI. I just want to see the information that's what the engine is telling me and giving me some responses there.
Yeah, and Alex, I would like to show everyone how the model is built and the show commands that we're using to figure out what we're going to land and what we're going to put out on the box after this runs.
Okay. So yeah, based on this preview, right, this is comparing against what's running on the configuration. I can see the full logs. I can download the logs in case there's some troubleshooting that's needed and I need to go see everything that has happened. And I can create a ticket with Gluware, right, if that's the case. I can see the CLI, and this is the full interaction that the engine has had with the device. Any command that was sent and received in the output will be displayed here, right?
And this is your change request.
This is-
so
yeah.
this is exactly what the tool is going to do, and you can simply copy and paste it into your change request because as the pendulum has swung very far in our direction, the scrutiny that changes are getting now are very, very deep, right? For obvious reasons, but that's the get out of jail free card.
So when I click on, so that was the raw CLI, and that's the full interaction with the device. When I go to process CLI, this is the engine figuring out, based on the decision making that I found, right? I found some ACLs that match my naming convention that are existing on the configuration, but it's not in my model. So the engine is deciding to remove those ACLs first, and then it's going to go ahead, in order, it's going to configure my access list. Even though in my model I don't specify the sequence number, the engine is intelligent enough that we can specify the sequence number of what order your ACL is going to, or the rule for your ACL is going to be put in. Then it will,
And that's a good point, because if you don't turn on any type of QoS on a box, it's going to put on auto QoS on a switch. And that's exactly what we removed. And quite often we find a new installation, no one has turned on QoS because it's a very long quality service policy. And that's what Alex and I worked on, to actually remove the QoS and land the proper quality service on switches as well as routers now.
right.
One other point to highlight here, and again, when you sit down with sales management, they tell you things you don't hear from Sal, but they were saying like it's extremely important to have that logging, to have the trackability as to who did what and what exactly they did, right? So this embedded in the project, it's capturing the users, and then you have a full log of everything that you've done, including all the interaction with the device. So a side benefit is if you hit an issue with the device, let's say you expose a vulnerability or a bug or something happens, and the vendor says, well, send me your logs. Well, it's capturing everything, so you can very easily send it off to the vendor. And a third piece, which came from Sal's management too, and actually just made it in this release. Alex, if you can zoom in on the node map. Again, we deconstructed a monolithic config file into feature blocks, right? Well, now you start to get into, well, who's changed it and when and what version is it at now? So what you see here is these feature blocks, every piece of, let's say we're kind of codifying your show run in the land of Cisco. Every piece becomes a versioned piece of policy. So anytime you change that policy and you hit save, we're incrementing the version number on it. And so you actually can version control, individual policies like your SNMP or your class maps or your, and you can see these are very early. Alex had a new installation, was just beginning to make changes. But actually version controlling your configuration down to a policy level is a very interesting notion. And it's something a lot of people are interested in.
So Alex, let's just take a quick look at the whole way the thing is constructed, from a feature concept to where the engine is doing a show run, how it's looking at the regex, and how it's landing the commands, because I think that is a very important distinction of what Gluware is doing.
Right. So, as Sal mentioned, the feature policy here, right, is a combination that's going to build the full QoS, right? Because sometimes in some items you could be just using one line of command and it could be just one thing. In the case of QoS, that combination is what's going to build my full QoS model. And that's, the access list, the class maps, policy map, and including adding the service policy commands to the interface. At that point, then your full QoS is configured, at least on that device. So as we combine all of these items here, right, while in the visual view here in the node instance map, they're not organized in a way that is going to be, that they're going to be deployed. but the way that they're going to be deployed is in the way that's organized, in the way that I select them, right? And I can move them up, I can add more items to it, right? I can filter them out. So everything is built through here. So this is the combination, is the feature policy. With this feature policy, you also have the capability of, over here, it was just a simple form that we created, but this form can be as extensive and it can be built by the user within the UI itself, right? So this form, you can create radio boxes, you can create arrays, you can create strings, anything that you want to be able to expose as a variable in your configuration, you can build it through the service policy. So at that time that you were doing a provisioning, you provide your variable points here, right? And then in the CLI piece, that's where you could call those variables. Now, if I look at the JSON view here, I'll be able to see, right, how do I call that variable, right? So we do what we call, at least when it comes from Gluware, if you're providing, there's two methods that you can provide a variable. One of them is when you provide it through your model, and we call that with just a $sign context. So we replace the form address here in this JSON with context. So if I were to call $sign context.interface.bandwidth, I would get the value in that form, in that JSON. Another way that you can provide custom values is discovered from the configuration itself. And that's a discovered item, right? That through the set of show run commands, we can create regular expressions that's going to grab that value, load that variable, that value into a variable, and allows you to reuse that value somewhere else.
We'll show that in the
And we're going to show that next, right? Or not next, but in the next demo. So the CLI, getting a step deeper into this, into what was built here, right? The CLI command group is essentially I make a reference to my CLI command list, which is my raw CLI. And within here, I use regular expressions to say, hey, I want to manage any class or policy map that matches with this name, right? And this is full regex support. You can include one as many, create ORs, right? So you can do pipe through. I want to manage any policy map that begins with this, this, or that.
And show the show run that's pulling that.
So
right?
that's what I was going to get to, right?
The whole trick.
And attached to that item is the what we call the concept item. And the concept item is essentially how do we read that configuration that's going to be related with this specific item. In this case, is a policy map, right? And we precede a set of these concept items, and we're constantly updating them and adding them as we discover more, whether it's use cases or new commands that come out, as the end user also has that ability to create them themselves. So in this case, right, in order for us to compare just the policy map, we don't want to compare the full configuration to what we've built. This is the command that will run, right, do a show run all section policy map is going to get me a printout of any policy maps existing on the configuration, and then it's going to use that output to compare versus what I've modeled, and then the engine will have the decision making of what needs to be removed, what needs to be added, or what needs to be updated, and we'll make the changes accordingly. So while it may seem, even though over here in the visual on the node map it's hierarchical, right? The execution process is going to execute from this end first, right? It executes the concept items. It does the information gathering first, gathers the information, then processes to the filterings in the CLI command group, and then based on that, whether it matches my naming conventions or it matches the sections of the configuration that I want to apply, then the engine at that point will have, okay, this is what I have modeled versus what I found, and matches my naming conventions. Now, what do I need to add or remove?
So QoS is a more complex example, obviously. We dove into something that is not a trivial example, but it is showing you the power, the flexibility. Just to show something simple, is there NTP, or I can't read your screen very well from here, but just to get the concept of a very simple feature, as you look at, again, the building blocks of what you're able to automate, it's very straightforward to say, okay, here's how we configure the statement, here's how we read the statement, and how we can actually automate it. And then by simply tying it to an assembly, we now, for all the devices that have that assembly, again, kind of like an intelligent template, we're going to make that change.
So in this right here, right, so this is one of the most simple setups that you would have. Let's say if I want to start, I want to update just usernames across all my devices. This is what you would create, right? So I have my concept item that's related with usernames, and I have the show run command that's going to gather that information, right? I have the CLI that I want to be able to output, right? And in this case, I'm providing variables that you can do a mix and match in here to where you can have variable endpoints, and you can also have, just straight up, just a static usernames if you'd like. So the CLI, and then on the command group, I don't want to save this guy here. Through the command group, I can create my naming conventions, right? And by my naming conventions, I can say I want to manage any username that starts out with Cisco or starts out with Gluware, or you can create a section of usernames that you want to touch to where you don't want to touch certain users that are on there. You wouldn't include that in this case, right? So if I want to touch all usernames, I can just create a regular expression that can add anything, any matching username that exists on the device.
Okay. So any questions on the QoS segment? Because we're going to jump into a second use case where we're looking at NAC on layer 2 switches. Any questions, guys? Okay.
And when you build the model, you'll have, I'll show it to you later, but we have a lot of those, like dozens of those threads of automation in the assembly now as we kept building and building and building, but the username was a good one, Alex. We haven't done that one yet.
Just a quick setup of this demonstration. As I was already talking about, NAC is a network administration control. It resides on generally access switches that people can plug into, so you want to secure the port. Again, there's the global level commands, there's port level. You don't want to put it on a trunk, you want to put it on an access port. And then as Sal was talking about the pre-Denali, post-Denali in Cisco's world, I think 16.3, it changed the configuration set. So it's not just completely straightforward. There's, in the Gluware terminology of conditional rendering to make decisions of where to apply the commands and then what commands to apply are all encompassed in this demonstration. So with that, we'll switch it back to the UI.
So with this use case here, right, this is when it comes to configuring switch ports, we do them somewhat a little bit different, right, in the way that we configure if we want to touch specific interfaces. So what we've done here is, you created naming conventions for the interfaces themselves, or for the interfaces on the devices, right, and how to talk to them, and what the model is going to be for this specific device. So in the case of NAC, we want to land, right, there's the global command that we want to land. When we did it with Merck, there was additional commands that were conditionals to any device that was post-Denali, right? So we had attached here to the side that was another item that would match, and it would be configured only if you match that condition, right? So we knew that all devices needed this command to turn on .1x globally, but then there was additional command that needed to be added, and that was only matched if it was a post-Denali iOS running. So with the global command, once that's configured, then you have the commands that are going to go on the interfaces themselves. And what we have here, right? So I'm simply specifying a variable that I'm not having to say, go configure on all these specific interfaces. I'm saying any interface that's going to match a condition. And the model that I want, I'm also creating a filter that only touch certain commands. As you don't see here, I don't have the switch port commands, anything related to any other configuration. I only want to touch what's part of NAC. On top of that, right, there was a VLAN that we needed to configure, at least in a specific use case, that we need to have a fallback VLAN that if I can't talk to my AAA server, then go ahead and configure the VLAN that's already on the interface. Now, he already had the deployment. Some interfaces had NAC, others didn't, others had misconfiguration. And you want to be able to configure the fallback, and the access VLAN is different on every interface, right? So this fallback VLAN, the requirement here was it needs to be the VLAN that's specific to that interface. Now, trying to create a model that is going to be specific to that is just impossible to or to create that manually. So we're created with conditions. Once we match the conditions, right, which in this case is if the interface is found to have an access mode, and I define, and this is the item that I touched on earlier, right, you're either going to find variables that come from $context or $discover. The $context, you're providing these variables from your policy, and it's going to be from a JSON. The $discover is going to be part of that concept item or that set of instructions that we created, and they are simply regular expressions that you can match that it's going to have on that interface. So essentially what I called that one, right, was $discover.vlan.access mode, meaning that I created a regular expression and I gave it a name that's called access mode if it matches this condition, right? Switch port mode access on our interface, then it's going to be set to true, and I'm going to go ahead and push that configuration. So let's see, and on that filter as well, I also created a list of allowed commands, right? Because I don't want the engine to go and remove configuration that's unrelated to NAC. So in this case, these were the commands here that I want to allow, and it's full reject support as well. So we're going to go ahead and run a preview here, and I'll be able to show the differentiation of what the engine finds, right? On some interfaces are going to have NAC, some others won't. Other ones are going to have misconfiguration, and based on that, the engine is going to give you the output of your desired state.
Yeah, and this is really the power of the tool that, you can really define exactly what you want to do. And if you want to touch some things, you can touch them. If you don't want to remove them or put them in, you don't have to. But this is exactly what we did. Ours looks a little different because there's many, many ways to do these threads of automation with Gluware. But the flexibility is amazing. And this is where we had to remove port security because it broke NAC, right? And that was found out till after we rolled out to thousands of switches. To say, oh, by the way, port security is breaking NAC, so we're able to fix it now.
So you can see as some of these interfaces here, right, I already have information. I have interface 2, I have a VLAN, but I don't have any switch port or any NAC configuration. I have interface 3 as well, switching back to the UI here, right? So I have interface 1 to where I'm configuring NAC, and I'm using the interface or the VLAN that is on my access interface there, right? And same thing with interface 3. I found on interface 4 that I have NAC configuration, but the fallback VLAN is not the same VLAN that is existing there, right? So even though my access VLAN is 100, I have my fallback VLAN as the 66, and the engine is resolving or fixing just that one line, even though the NAC is already configured on there. Right.
And just one other quick thing I'll mention about this. When I first started building this, we have all different types of switch stacks, any combination of 24, 48 port switches, 12 ports. When we first built it, we built models for all of them. And we said, well, why don't we just make an 8-stack, 48-port model, and we use that for everything? Because if it doesn't find those commands, it will not land the commands or move the commands, which was so we really just have, common services NAC open, common services NAC closed, and that's really it. We're building one for security cameras now because it's still a little gray area what we need on security cameras, what we don't need. But moving forward, as we move forward into the 9300s to have Essentials license, we're going to build multicasting for security networks with Glue, and we're going to build multicasting for audio-video networks because we have a lot of digital signage and that type of stuff too. So that's kind of where we're going next at this point, and we'll do it with these existing models we have by just adding another block to the tool.
Yep. And so NAC was a good example of another fairly complicated technology to deploy. And if you had to do it manually, it's brutal, and you can see how a change window can take an hour per device. And your management was big on IQ, OQs, right? Like installation qualification and operational qualifications, all with pre-checks, post-checks, and you write those procedures. So if you can see where if this was done manually, what would be the duration to roll out on hundreds or thousands of switches? It would be a painful project. By automating, putting the time in up front to make the definitions in the product and then intelligently push it out, I mean, it is really a game changer. So it's been very effective for Merck.
Oh, yeah.
Sal, now, again, NAC being a complicated feature, if you will, you also did a bunch of the globals on layer 2 switches. So what, SNMP and NAT?
Yeah, layer 2 switches are done at this point. We built some models. Again, we have to really drill in and see what we really need on a shop floor switch, because all of our shop floors are different, right? They're very, very different. Some of them have private VLANs on them, some have a lot of things. So we're really at the point now where our basic models are done for all types of layer 2 switches, whether they're 3750Xs. Any iOS XE switch has just one model now. And like I said, I mentioned before, it's a logistical problem at Merck now, importing all these devices, because the name of the switch isn't indicative of what it's doing, right? And we don't want to, no RGEs again, right? We don't want to push NAC to a shop floor switch. We'll actually break quite a few things. So that is my biggest challenge right now. But we do have this model, and I have from the ops guys what the series of commands that they do to do a pre-check on a switch. So we're going to use Glue to automate this, and just to, like, we import a bunch of switches. We'll do a pre-check with Glue and see what dysfunction the network is, because you'll be able to tell that way, right? And
Yeah.
get that data. That's it's not the technology right now. It's the logistics of
Right.
identifying what type of device it is on our network.
And this reminds me of a statement I think Greg made, which was like, human engineered, but, software automated, right? You
Right.
still, it doesn't take away the engineering component. And now you're able to do the value added tasks instead of like the mundane and these
sure.
manual tasks. And so with that concludes demo number 2.